Hello and welcome to Mathematics Made Easier channel. I am your favorite mathematics teacher, Comfort Amwakum Atta. For those joining me for the first time, a special welcome goes to you all. If you are yet to subscribe, please look down there and click on the subscribe button to subscribe. Then you click on the notification bell to receive updates all the time. It is all about mathematics. That is making mathematics very easy to solve. Right. Okay, so the question we have on board here is, I gave it out in my previous lesson, and I asked you to try your hands on it. Those who had the answers correct, bravo. But if you were not able to solve it, don't be worried. After solving it, go through and see where you got stuck. Then you correct yourself. All right, now pick your journal text with your solutions and let's go through today's class together. Right. The question was, a diagram shows a belt QRST round a shaft R of negligible radius and a pulley of radius 0.6 meters. 0 is the center of the pulley. So O is the center of the pulley. Then we have line OR as 1.5 meters. And the straight portion QR and QS. QR and good. QS, QR and RS. This one QR and RS of the belt are tangent to Q and S to the pulley. Calculate the angle QOS, correct, QOS, correct to the nearest degree. Then II, the total length of the belt to the nearest meter. Okay, so I always say that questions involving diagram, I will encourage my students to draw the diagram. So now let's redraw our diagram. That is what I've drawn over here. Okay, so we have QRST. Good. Now from the question, what did they say? They said line OR is 1.5 meters. So where is your line OR? OR. So it means we have to create a line to this. Line OR is what? 1.5 meters. Good. Then they are asking us to find angle QOS. All right, so this is the angle. So we have an angle here, another angle here. So that is what they are asking us to find. Now we are having two right angle triangles forming over here. Good. So now let's continue. They are saying that. Let's see from the question, everything that you need. Okay, so they gave us the radius of what? 0.6 meters. So radius of 0.6 meters. Great. Now, how do we find the angle over here? We know that angle QOS, that is the angle that they're asking us to find. Angle QOS is equal to 2 times angle, I believe angle SOR. SOR. Since we know this side, the moment we are able to get this angle, we just multiply by 2 to get the whole angle over here. Great. So with this one, which of the trig identities you think we are going to apply over here? I believe you've not forgotten it because we taught this or we treated this in our previous lesson. Okay, so let's bring out the right angle triangle. Okay, we have our theta here. This is giving us S, R. Then we have what? O over here. Okay. So which of the three identities 0.6 meters, then 1.5 meters? So this is directly opposite to this. We don't need this side. Since we know this side and this side, we are going to apply Ka. This is opposite. This is adjacent. Adjacent. And this is what hypotenuse. All right. So Ka, A-H. We are going to use cos theta is equal to, where is the A? Ka is what? Adjacent over hypotenuse. All right. So A is what? 0.6 over hypotenuse is what? 1.5. All right, so now punch this for me. What are you going to get? Yes. I'm waiting for you. Okay, so I am having 0.4. 0.4. Okay, so this is cos theta is equal to what? 0.4. We want theta, that is the angle, not cos theta. So I believe you remember that one too. Trig inverse. Good, all right. So since we have cos theta is equal to 0.4, we just have to write the theta and have the cos inverse of 0.4. All right, so point this for me. Now I believe you remember how we point this to the cos inverse. Shift cos, then the 0.4. And I am getting 66.42 degrees. 66.42. It means that angle SOR is giving us a 66.42 degrees. All right. But note that we stated that we are to find angle QOS. And we stated that angle QOS is equal to 2 times angle SOR. So since we've been able to get our angle SOR, we just multiply by 2 times 66.42. That will give us 132.84 degrees. All right. So therefore, we can say that angle QOS, that is what we are looking for, QOS, is equal to 132.84 degrees. That is not the final answer. The final answer was correct the nearest degree. So how do we correct this to the nearest degree? The nearest whole number, right? So therefore, we are getting angle QOS to be 132 degrees. So simple. So before we were able to get this, we had to find one side and multiply by 2 to get a whole of this side. Okay, so let's continue. The B part of the question, but the second part is what? Find the total length of the belt. Okay, so how do you find the total? Right, so now let's come to the right angle triangle that we drew over here, this one. Okay, so that was this, right? So SRO, then 0.6, 1.5, 0.6 meters, and 1.5 meters. So we have to find the side. Okay. So what do you think we can apply in finding line SR? Good, the Pythagoras theorem. So using the Pythagoras theory, we are going to have line RO squared is equal to line RS squared plus line SO squared. We have the line OR squared as what? 1.5. So 1.5 squared is equal to line RS unknown, which is x squared plus 0.6 squared. We want x squared, so let's multiply times. We are getting 1.5 all squared minus 0.6 all squared. So please simplify this for me and tell me the answer. Okay, let me write straight away to x equal to, let's square root both sides, get rid of the square here. The square root, so 1.5 squared minus 0.6 squared. All right, so let's simplify this. And we are getting x to be, I want the first person tell me the answer. And I'll give you a surprise. Good. All right, so I'm getting it as 1.375 meters. 1.375 meters. So that is line SR. Okay. Line SR is 1.375 meters. Okay. But let's see that. Let's see this side. Let's go back to our diagram. But line SR is equal to line QR. Good. So line, so you can say, but line SR is equal to line what? Line QR. Line QR. That is giving us 1.37 meters. Okay. So we are looking for the total length. Since we are looking for the total length is going to give us, let's go back to the diagram. It's going to give us line SR plus line QR plus the major arc. Okay, plus the major arc. So this is giving us line SR plus line QR plus major arc. Okay, all right, line major arc. All right, so now we've gotten two of it. We've been able to get the line SR and line QR. We are left with the major arc. Good. So how do we find the major arc? So now length of the major arc equal to, let's say, alpha over 360 degrees times 2 pi r. How do you find the alpha? That is 360 degrees minus, let's go back to the diagram so everything becomes very clear to you, minus QOS. So minus angle QOS. QOS. Do you know angle 3OS, angle QOS? Yes. We're able to find that angle as, let's see, okay, as 132.84. So this minus 132.84, right? So simplifying this, subtract this for me, and you are getting 227.16 degrees. This is an angle, right? 0.16 degrees. All right. So now we just do a simple substitution. Okay, simple substitution. So the alpha was 360 degrees times 2 pi r. Pi was given in the question as 3.14 key. And now we've gotten the alpha as what? 227.16. So 227.16 over 360 degrees times 2 times 3.142 times, what is the radius in the question? The radius was given as what? 0.6. That's what? 0.6. Great. Times 0.6. Now I want you to simplify this for me. What are we getting over here? Good. I am getting 2.379 meters. So if you are getting a different thing, check your solution well. Okay, so it is the total length. And as I said earlier on, the total length is equal to the total length is equal to let's go back to the diagram. It's equal to line SR plus line QR plus line SR plus line QR plus the length of the major arc. Length of the major arc. Length of the major arc. And now we know all the parts. What did we get for line SR? We had 1.37. So just do a simple substitution. So 1.37 plus, let's add the unit to it, plus, we said line SR is equal to line QR. That is this side. Line SR is equal to line QR. So if this side is 1.37, it means you're getting this side to the same measurement. Plus, now the length of the major arc, we had it as what? 2.379. All right, so now add all these up and tell me the final answer. Okay, so I am getting it as 5.127 meters. Okay, but the question didn't end there. The question was, correct it to the nearest meter, nearest whole number. So with this one, we are getting, what will be the nearest meter? So approximating it to 5 brackets to the nearest meter, the nearest. That is all. So simple. So when you see the question, take your time and break it down into bits. This every information you will need to solve the question will be given in the question. If O is the center, it will be given to you as O at the center. Every length or the side that you need to solve the question will be given in the question. Thank you so much for your time. Take this as your assignment and try your hands on it. All right, so this is your take-home assignment. A circle has a radius of 7.5 centimeters with an angle of 240 degrees is cut out from the circle. A, find the length of the arc of the sector. I believe you remember the length of an arc of a sector. Good. B, if the sector is folded to form a cone, find correct one decimal place. I, the radius of the cone. I, the height of the cone. And I, the volume of the cone. This is similar to the first one in the previous lesson, the first one that we solved. So take your time and digest. I believe you get the answer correct. And I will encourage you to solve more questions on your own as well. For those preparing for Wassce, please sit up and solve more questions on your own. Thank you so much for your time. I believe this tutorial was helpful. Don't forget to share the links to your friends out there for everyone to benefit. So we meet again. Please stay safe and learn hard. Bye.